Good afternoon, everybody. Welcome to our next presentation from Dr. Ciro Noronha from Cobalt Digital. He's going to be talking about a new feature of RIST, the Reliable Internet Stream Transport Protocol, the RIST Relay, and talking about all the good things that RIST Relay brings to the RIST universe. So, welcome, Ciro.
Thank you, Wes. So let's talk about this RIST Relay. And point I need to make is this is going to be an open specification when it's published. Not published yet, but it will be open. So what's the problem we're trying to solve? You have a RIST client, a RIST server, and the RIST client wants to connect to the RIST server. And the internet's in between, and everybody uses firewalls. So at the client side, the firewall is not a problem. It's an outgoing connection, so very, very simple. Firewall on the server side is not going to let that connection in because that's what firewalls are for. So what you got to do? You got to talk to someone in the IT department to open a port, one or more ports, depending what you're doing. So the question is, can we make this happen without involving IT? Just like Skype. You don't want to deal with it. It just has to happen, right? So what is the generic solution for that? You throw in a server. The server will help the endpoints to communicate. That is the RIST relay. That's where it sits. It's a server outside that helps them communicate. All right, why RIST? Well, first of all, why do we do anything in this industry? Because users want that. So they have asked for mechanisms to simplify firewall crossing because of that DMIT department. So, and also RIST devices may be guests on some third-party network. You drag something to a hotel for an event. So we may not even know where the IT guys is. So why do we have a common specification? You can mix and match clients, servers, and relay points. By mix and match, I mean use it from different vendors. We do it in such a way that vendors can still innovate. So they can create innovative solutions. And since we are in this to maybe make some money, right? There's multiple business opportunities. You can be providing the software, you can providing a server, or you can be providing a service. So next thing you're going to ask me is, are there solutions for that? Stuff like stun and turn and ice. There is, so what's wrong with that? These are not complete solutions. See, the list is growing, right? Stun is just for you to define your public IP address. Turn is a relay server. ICE is a means to renegotiate that. And you still need something like a SIP server for the clients to decide to discover each other. And there's some security issues. So for security, it is necessary, if you want best possible security, it is necessary to combine all these functions into a single server. And this is what we did. The RIST AG elected to reuse the RIST security model, which is very, very, very secure. Well, as secure as we can be. There's never absolute security, right? But it's very secure. And we just decided to design a complete solution using RIST Advanced Profile. So before we dive into the solution, let's take a closer look at firewalls. So there's two types of NAT firewalls. There is asymmetric firewalls where the outgoing traffic creates a temporary rule and any return traffic matching the port is admitted in the network. So the stuff you buy out on consumer level stuff is mostly asymmetric. And using those things is possible to do something called a direct bypass, which I'll show you later. There is also symmetric firewalls where the IP address is added to the rule, and only return address is allowed that matches that from that host is allowed into that firewall. Most high security firewalls in corporations are that. And in this case, direct bypass is not possible. So let me show you how it goes. Let's start with an asymmetric firewall. So in this, device A wants to talk to device B. So, but he's going to talk to the server first. And it sends a packet to the server, with some source IP address import. The firewall maps that, just like every firewall, and creates a rule. Packets from this guy are forwarded to that guy. The rule is to actually match the return packets. So the server then tells, oh, device A can be reached at the IP address import of the firewall. And then it tries to get in. Since it's the packet coming in is matching the port, it goes through. So it works. So using this server, we could get a direct bypass between device A and device B, as long as they know that they need to communicate with a server in the middle mediating. An asymmetric firewall, and I reuse most of the slides, so it's easy to make, right? Is not going to work. When the packet goes out, it creates the rule. There's the red part from the server. The rule to come back is from the server. So if the server says device A can be reached at that point, device B tries to reach it, it's not going to go because it's coming from the wrong IP address. So most high security firewalls from typically using corporations work like that. So why do I go through this? Because that has implications on the design of the protocol. Asymmetric firewalls allow endpoints to connect directly, which is a very desirable from a bandwidth point of view because you don't have a hotspot in the server. The server is only involved in the connection establishment, but there's lower security in the firewall. Symmetric firewalls only allows endpoints to connect to a server. That's why you have something like turn, because at that point, the server must be able to relay the traffic. So this is why we ended up calling this RIST relay. Original name was rendezvous point, but there's people in multicast routing that use rendezvous already. That was some confusion. And what we're doing is a relay. So what are the requirements? Endpoints must, first requirement to this solution, endpoints must log in and be authenticated, since this is working around the firewall. So security is very important. So you got to be registered to be allowed. And since the endpoints can connect to anywhere, you need to provide some sort of directory service. Yes, we are doing something like SIP, but that's necessary. Now, we should also be able to facilitate direct bypass connections, because if it's capable, we should allow that. We shouldn't deny that. You could just design a relay and be done with it, but if direct bypass is possible, we should know. So there's no way to know that if bypass is working until it's tried, so you must be able to relay. And you need, if you're an endpoint, you need to have some control of what happens. I've been harping about security, so let's talk about security. In order to preserve security, the endpoints must establish a RIST advanced profile with both encryption and authentication. There are several options in RIST advanced profile. The first one is DTLS with certificate-based authentication. This is what your bank uses. We could use DTLS with TLS SRP with some username password authentication. Or you could use the RIST PSK with the EAP authentication, which is the next talk after that. The guys who designed that are going to come talk to you about that. So it's a very interesting protocol. Or you could use WireGuard, which is something that RIST is adopting as well as an option. The authentication then will identify the endpoint to the relay, and endpoints then are identified by a human readable name. So you don't want to use some weird combination. So human readable names are what identify the endpoint, and we will see what that means later. All right. I've been talking about the RIST Advanced Profile. It's been available for a while. I'm going to do a quick recap. I promise it's only one slide. So it's published as TR063. It's freely available. That's what I like about the VSF. You don't have to pay. I'm needling some other organizations. It's free. Go and download. Don't have to pay. All right. Advanced Profile Basics. It provides a tunnel encapsulated in RTP. There's packet loss protection using ARC and FEC to the tunnel, multiple encryption authentication options, supports encapsulation of multiple protocols, so that's nice because the relay is going to have to support that. And it also includes a control channel. This is important because we use this control channel. It's already defined in advanced profile to do the RIST relay. So let's talk about the communication protocol. Since I've talked about the control channel, let's talk about the communication protocol. There's something called the RIST Advanced Profiles control messages. It's already part of the advanced profile. And we define a new set of messages. If you're familiar with RIST Advanced Profile, here they go. There's a 16-bit control index that defines the message. This is all defined in RIST Advanced Profile. And we defined a new set of messages. The blue ones are from the RIST relay to the node, and the green ones is from the node to the RIST relay. And these messages are not protected by ARQ. So the protocol takes into account packet loss. I'm not going to get into details of what happens with packet loss, but no ARQ is applied to this. Messages are encrypted, and very important, you have the option of saying no. I want this. No, you can't have it. There's a message for that. There's something called the keep alive message, part of the RIST protocol that keeps the connection alive, keeps it open. Let's take a look at the general operation. Endpoint connects and receives one of the following. I'm ready. I'm busy, go away. There's an actual message. I'm busy, go away. I don't have resources, right? Go talk to this other guy, probably because I'm busy. So instead of saying go away, go talk to this guy. So let's say you connected. You connect to the endpoint. The endpoint says, I'm ready. What do you want? And then you say what you want. I wish to connect to some other endpoint. And you define that by the name, that human readable name. I'm ready to accept connection. So you connect, but you're just sitting there. Someone's going to connect to you. Give me a directory list. I want to know who's connected, or who do you know about? I'm not ready to do anything. So I'm connected. I don't want to receive a connection, but I don't want to connect to anybody either. I'm just connecting to be ready for the future. So it's important. So I have a slide about that. You can say no. You can say no to any request. The request denied message includes information to identify the request itself. So you're denying something. What is it that you're denying? And a reason. So unspecified reason, I don't want to tell you. No, and I don't want to tell you. No, you're not authorized to do that. For example, give me the directory list. You're not authorized. Not found. I want to connect to John, and John, I don't know about John. John is not connected right now, or John doesn't exist. And again, you can choose what to do. That's the innovation part. The protocol is flexible, and the vendors can do what they want, right? RR is out of resources. No, when you connected to me, I was okay, but now I'm busy. So not going to happen. The other guy doesn't want to talk to you. John doesn't like you. Or you screwed up the protocol, the request is invalid. Or incompatible protocol. Why incompatible protocol? Because there's multiple encapsulations in RIST Advanced Profile, and there's no protocol that you guys speak in common. And invalid requested IP address. There was a big discussion in RIST AG about that. I don't like a region of the world, but that's not PC. So invalid IP address is what we say. I don't like your IP address. Whatever. Why? I don't know. All right. So protocol support. Advanced Profile has multiple inner protocols. That's why I said about the invalid protocol. So when an endpoint connects, it must declare what options it supports, and it must declare where it's willing to accept bypass. Maybe you are behind a corporate firewall that you already know it's symmetric, and you just say, no, I'm not going to take bypass. I know it's not going to work. RIST relay, that's important, can relay data packets across different encryption modes, but the actual data is opaque to the RR. So if you have a WireGuard connection and a DTLS connection, it can relay between them, but it's not going to look at the data. That support information is part of the connection initiation and response, and I have a nice animation for that. This is returned in directory when you say, give me a directory list, all these guys are there, and you know what they support. So I know it's a lot. Those are the flags. So I don't expect you to read the flags, but I'm going to show what they mean. The first two is for bypass, and IPv4, IPv6. And I apologize, this is a little small, but it was a bit laziness on my part. The other one is encryption support. I do WireGuard, I do DTLS, or I do PSK, and that gentleman over there is going to talk to you about PSK after me. And then what packet recovery support do I have? So ARQ, packet recovery by ARQ or by FAC, and there's two versions of FAC, 2022-1 or -5. And a lot of them, all of the same time, is the encapsulations, right? I do media 2110, I can do TS, I can do main profile, I can do Ethernet. So those are the protocols I support. This is not a complete set, but they are the most important. The blob. Are you talking about the blob? Again, someone else in this audience came up with the blob. When you register with the RR, it may include an ephemeral blob. And the blob is exactly what what it says, a bunch of data that the RR will send from one side to another side. And we tell you what that data is. It's more for authentication. It's another level of authentication because we are very concerned about security. So what's in the blob today? An endpoint certificate. Because if they're going to go direct, you want to redo the certification. A CA certificate or a combination. There's also an option of vendor proprietary blobs, but we don't like that because it has an interoperability problem. Multi-point operation, because maybe you're making a CDN and you send one stream and then it goes to a whole bunch of stuff. So we need to support that. Let me talk to you about multi-point authentication. We support multi-point to multi-points, not only point-to-point, multi-point to multi-point, using something called groups. Yeah, great work, right? It's been around forever. A group is identified by a name. So you create a name, and you say, this is a group. You connect to that, it's going to be a group. It's going to be relayed to everybody. Groups are created manually through out-of-band means, meaning we didn't define a protocol for that. Is configuration. The administrator of the RR is going to create a group for you. When you get the directory listing, you take a bit to say, this is a group, and the RR is responsible for replicating the data to all group members. So how do you implement that? The nice thing about the implementation is that it's not dictated by the specification. You can do, these are examples. That's an informative part of the document. You as a vendor, if you decide to make this, you have choices. So one choice is full proxy. You terminate all the connections, you do a RIST advanced profile, and you do all the packet loss recovery between the RR and the endpoint, and that gives you the maximum ARQ bandwidth efficiency and lowest latency. We can provide format conversion if desired, or we can do transparent. So full proxy is one thing, transparent is you just forward. You don't know what it is, you don't care, you just forward. And let the endpoints take care of packet recovery. Packet recovery is end-to-end, so that has inefficiencies because if one guy loses a packet, everybody's going to see that because the RR is just replicating, so it's inefficient. And latency has to be the worst case. And you can do partial proxies. So when the document is published, it's not published yet, we'll have a discussion on that. But the nice thing about this set of VSF standards is we define a framework, and you can be creative in that framework. Let's talk about the directory query. You can ask the RR for a directory of connected endpoints. And the response you can take what's the name? What's the type, individual or group? What protocols do you support? Because you need to know if you can talk to him. And the filtering, the access control and filtering up to the are not part of the specification. Again, the point I keep making, if you're a vendor, you're implementing this, you can innovate. So if you want to give different directory views to different guys or different endpoints, it's your business. Concurrent connections. Can an endpoint have multiple connections? The endpoint may have multiple idle ready-to-receive connections to the RR. That's for redundancy. Maybe you have multiple connections to the internet, and you can have multiple connections to the RR. So we support that. If the RR gets a connection request for that endpoint, we'll choose one of the ready-to-receive ones, and you can use the protocol support flags to inform that choice. But each endpoint is listed only one in the directory. We had a big discussion about that, and that's the conclusion. So, time for some nice animations, see if people wake up. So let's see, connecting to the RR. You start with, the endpoint is always a client, the RR is a server. So you send an authenticated connection. This is defined by RIST Advanced Profile. Then you see that message, the things I said. I'm ready, your name is this, I'm busy, go away, or redirect. And then you have a response, which includes the protocol support flags, and the response will be, give me the directory, connect, I'm not ready, I'm just connecting to you to be ready for something later, or I'm ready to receive. You can send that connection initiation again later to change your state. For example, you connect and say, not ready yet, stay idle, and then you say, either I'm ready to receive or connect me to someone. But you have that connection, and the Advanced Profile Keep Alive mechanism keeps it warm. So let's look at the connection to the endpoint. You say, connect me to YY. YY is the one on the left. And then you will see something, the one on the left that's connected in ready to receive mode. You will see a connection incoming message says, XX wants to connect. And in that message, you'll say, he wants to use bypass, or he wants to use the RR. And the response, let's say connection is accepted, and the response comes back from the RR saying, connect to him through the RR, or connect to him using this particular IP import if you're going direct, or if you're going bypass. This part is important. The other guys asked first if he wants to be contacted. It's there, it's ready, it's idle, it's waiting to receive a connection, but you give him another chance, a last chance to say no. And this is an example of him saying no. Connect to him, XX wants to connect, and you can say connection rejected, and then a request denied, connection refused by the endpoint. All right? I don't do a lot of protocol stuff in my talks because that puts people to sleep. So let's stop here and get to conclusions. The RIST relay will simplify support for establishing RIST connections for endpoints behind firewalls. So let's not, in other words, let's not bother the IT people. They are very busy. By using a common specification, you can mix and match RR and endpoint vendors. So I'm not here to sell you anything. I'm here to convince you that there is a standard, a specification, not allowed to use the word standard, and you can implement to that. And we do only the minimum for interoperability, allowing the vendors to innovate. This is still work in progress, and no implementations exist yet. Questions?
All right. Thank you very much, Ciro. Anybody have any questions? Okay. We don't see any, so thank you very much, Ciro.
Welcome. Thank you, Wes.